In Chapter 7, we're going to be looking at estimating parameters and determining sample sizes. For 7.1, it's going to be really focusing in on that estimating population proportion. So your objectives in this lesson will be to estimate population proportion using point estimates and interval estimates, interpret confidence intervals for population proportion, and find the minimum sample size needed for a given confidence level and margin of error. So here's a look at what we are going to be doing. If you start with a question like how much do newborn babies weigh on average, that's not a super specific question. So then let's look at it this way. How much do newborn babies in the U.S. weigh on average? So there we are more specific. Even though it's not that interesting, we have now specified that it is U.S. newborn babies. So perhaps we're curious about the impact of smoking on newborn baby weights. So one way to word the question would be, how much do newborn babies in the U.S. weigh when their mother smokes during pregnancy? Then you can compare the answers to that question to the question above to it to understand the impact. So you could compare the second question to the third. There are two types of estimates we can use to answer the baby weight questions, a point estimate and an interval estimate. Interval estimates are also called confidence intervals. You have point estimate is a single number value that estimates a population parameter. An example would be one study of 400 newborns had a sample mean weight of 7.7 pounds. Therefore, we estimate that the true population mean weight of all newborns is 7.7 pounds. So the point estimate is in bold, where we're saying it had a sample mean of 7.7 pounds. A confidence interval is a range of values that has a high likelihood of including a population parameter. For example, based on a study of 400 newborns, we are 95% confident that the true population mean weight of all newborns is between 7.5 and 7.9 pounds. You can see that confidence interval in bold in the example above. So to estimate a population proportion, the most unbiased point estimate for a population proportion P is the sample proportion P hat. This will be what we look at the estimate in 7.1. To estimate a population mean, the most unbiased point estimate for mu is the sample mean x bar. And we will discuss this estimate in 7.2. So because it is risky to put all of our eggs in one basket by using a single point estimate, we more often use interval estimates attached to a certain confidence level. So to do this, you want to say first, decide on a confidence level that you want. How sure do you want to be that your interval contains the true parameter? Collect data using as large of a sample as possible. Calculate the point estimate. Then you're going to calculate the margin of error, and you'll add and subtract that value to your point estimate to get a confidence interval. All confidence intervals have a confidence level, which is a degree of certainty that we have that the interval truly does contain the parameter we're estimating. This is often expressed as C or as 1 minus alpha. If C is the level of confidence that our interval is right, then alpha is the probability that our interval is wrong. And this number, alpha, is also called a significance level. Confidence and significance are related in complementary events. So that means that C and alpha add to be 1. You will also learn more about significance in Chapter 8. The most common confidence levels are 90%, 95%, and 99%. For example, we said that based on a study of 400 newborns, we are 95% confident that the true population mean weight of all newborns is between 7.5 and 7.9 pounds. Notice that we have that 95% confident in that interpretation. So we're saying that confidence level so that whoever may be reading this also knows how confident we are. So again, just that relationship between the confidence level and alpha. The table shows the relationship between the confidence level and the corresponding value of alpha. The confidence level of 95% is the value most often used. In a standard normal distribution, alpha is the area in both tails. So alpha over 2 divided by 2 is the area in one tail. So what we're saying is when you're looking at that 90% confidence level, we're looking at a standard normal curve. So that alpha of 0.1 is actually both of these areas. So that represents alpha. So to get one tail, you would have to divide by 2. A critical value is the number on the borderline separating sample statistics that are significantly high or significantly low from those that are not significant. The number z sub alpha over 2 is a z-score that has an area to the right of alpha over 2. The confidence level is going to be that area in the middle, and that's that yellow area is the confidence level. Those green tails is our alpha over 2, and then the z, as you can see, I'll try to highlight that for you guys so you can see it a little bit better. So our z would be right here, and you can see that that is going to be found in Excel. To define the critical value z sub alpha over 2 for a confidence level of 95%, so we are looking for a z-score where 95% of the area is in the middle. So that means that just remember, okay, if I'm looking in the middle and this is 95%, then I only have 5%, but that's split among both tails. So then that's 2.5% and 2.5%. So really, if my z is here, z sub alpha over 2, then this side is actually 97.5%. So you have to keep that in mind when you're finding these critical values. So there is a formula in Excel that we can use to find that value, and that's your norm.inverse. Now remember, you can use norm.inverse and then 0.975 and then your mean and your standard deviation. Because we're working with standard normal, you could also use that norm.s.inverse, and then you would just be putting 0.975, and you're still going to get that approximately 1.96 value. Here you can see that same thing of just a reminder of why it is 0.975 and not 0.95. So this is just that good reminder of the breakdown again. So margin of error is the amount of distance that a point estimate could be from the parameter, and that parameter still be in the confidence interval. We will denote the margin of error by E. Half of the total width of the confidence interval is E, and the distance from the point estimate, so that's your middle value, to either endpoint of the confidence interval. So here you can see an example of a margin of error. Again, this is that based on the study of 400 newborns, we are 95% confident that the true population mean weight of all newborns is between 7.5 and 7.9 pounds. And you can see a graph of this confidence interval. So I'm going to show you a little more on each side so that you can see these different pieces. I just want you guys to see how you can get some of these values just by looking at an interval. So you could figure out the point estimate If you do 7.5 plus 7.9 and divide that by 2, you actually can get that point estimate. And then from the point estimate to an endpoint, so just looking here, that is a margin of error, and then there's one on the other side as well. So there's a margin of error. So you can find a margin of error if you do your upper endpoint minus your lower endpoint. 7.9 minus 7.5 divide that by 2. That actually would give you your margin of error. And you can see that from the lower endpoint to the upper endpoint, that is your total width of your confidence interval. And if you do 7.9 minus 7.5, you get 0.4. So a population proportion is the proportion of a group that has a certain characteristic. It is often reported as a percentage. Proportion of voters who support a certain candidate, a proportion of cancer patients who survive past 5 years, proportion of customers who earn more than $35,000, a proportion of capacitators that are defective. These are all examples of population proportion. Some notation for estimating population proportion. P is our population proportion. P hat is going to be the sample proportion. Q hat will be the sample failure rate, and you can find Q hat by doing 1 minus P hat. E is our margin of error. N is our sample size. X is the number of successes, just as in binomials. And Z sub alpha over 2 is your critical Z score. The steps to estimating a population proportion, the first thing that you want to do is find the point estimate. So you have to find your P hat. You're going to find P hat by doing X divided by N. Then you will find the critical value, Z sub alpha over 2, based on the given confidence level. And that's where you're going to do your norm dot inverse. And remember, you can use either norm dot inverse and then that 1 minus alpha over 2, 0, 1, or you can use norm dot S dot inverse, and then it would just be that 1 minus alpha over 2. The third step is to determine the margin of error, E, and to find the margin of error, you're going to say your Z sub alpha over 2 times the square root of P hat times Q hat divided by N. Again, you're doing all of this in Excel, and I have a way that I always set these up so that it isn't confusing and you don't miss anything. Step 4 is to subtract E from P hat, and this will be your lower endpoint, and then add E to P hat, and this will be your upper endpoint. And then the fifth thing is always finish by using a sentence to interpret the confidence interval in the context of the situation. So in terms of the problem, make sure you do a interpretation. As I said earlier, I always set these up the same way in Excel. So whenever I'm working with a population proportion, I am going to do this same setup. So I do my X value, my N value, my confidence level, and then your alpha. And remember, that's going to be 1 minus your confidence level. Then I do alpha divided by 2, P hat, Q hat, 1 minus alpha over 2, and then you'll use that value to find your Z sub alpha over 2. Then you can find your E, and then your lower and your upper. So after you find your confidence interval, you want to make sure that you do that interpretation. So we're going to look at what we need to be in our sentence. So remember that parameters are fixed numbers. They are either in the interval or they're not. Do not use the word probability or chance in your interpretation because it may imply the parameter is moving around. Always include 4 things in your sentence. What is the confidence level that you used? What is the parameter that you are estimating? Put the actual interval in there and put it in context of the problem. There are some requirements in order to find the confidence interval for P. The first thing is that the sample is a random sample. The second thing is the conditions for the binomial distribution are satisfied. So there's a fixed number of trials. The trials are independent. There are two categories for outcomes, success and failure, and the probabilities remain constant for each trial. There are at least 5 successes and at least 5 failures in the sample. So we're going to take a look at an example of a Facebook poll. It says a Gallup poll of 1,487 adults showed that 639 of them use Facebook. Use this sample data to find a 95% confidence interval for the proportion of all adults who use Facebook. I'm going to go through this example here, doing those 5 steps for the Facebook poll. You'll also see a little quick shot of my Excel, but there will be a separate Excel video for finding a interval. So the first thing is to find that p-hat. So to find p-hat, you're going to do your 639 over the 1487. Then you have to find your z. Okay, remember that's your norm.inverse. Or you could do norm.s.inverse and 0.975. Make sure that you are not rounding. You do not want to round until the very, very end. So keep that value, and then use cell referencing when you're working in Excel to avoid any rounding errors. Of course, after you find your E, you're going to add and subtract to p-hat, and that's going to give your lower value and your upper. And then you're going to write your interpretation. So we are 95% confident that the true proportion of all adults who use Facebook is between 40.5% and 45.5%. So here is my example from Facebook. Notice that I'm putting my X value, my N, and those came from the problem. And the confidence level was also from the problem. It asked us to create a 95% confidence interval. Then you can find your alpha by doing 1 minus your confidence level. And then I divide alpha by 2. I have my p-hat. P-hat is, of course, your x divided by n. Q-hat is just 1 minus p-hat. And then I'm jumping back down and working with that alpha again. So I need that 1 minus alpha over 2. And that gives me my 0.975. And remember, this is the value that you're actually using when you're finding that z-score. So that's why I have it in here right above where I'm finding my z-score. Then I find my z-score. So I used norm.s.inverse and used the 1 minus alpha over 2 there. Then you find E, and remember that formula for E, and you do need to be careful. I know I have it written out here, but just as a reminder, it is Z sub alpha over 2 times the square root of P hat times Q hat divided by N. And you want to make sure that you're careful, and you can see how I entered that into Excel there. So just so you can see that formula together with E. And then you're going to do your lower point and your upper point by adding and subtracting. So you'll do P hat minus E and P hat plus E. So there are different ways to write an interval. Remember that E means the margin of error, and that's why we add or subtract to the point estimate. P hat means the sample proportion. And if we're making an interval for P, it's the point estimate. So P hat minus E is your lower endpoint of our interval, and P hat plus E is your upper endpoint of our interval. So you could see it written in some different ways. We could use inequalities, interval notation, using a plus or minus, or actually using words. So these are all different ways you could see intervals written. I did show you how to find a point estimate and E from a confidence interval in the slide that had just the interval graphed on it. Just remember you can find the point estimate for P if you do the upper confidence interval limit plus the lower divided by 2. You can find the margin of error by doing the upper confidence interval limit minus the lower confidence interval limit divided by 2. Here, let's look at an example of finding a sample proportion and margin of error. We have the article High Dose Nicotine Patch Therapy by Dale Hurt, and it's from the Journal of the American Medical Association. It includes the statement of the 71 subjects, 70% were absent from smoking at least 8 weeks. 95% confidence interval of 58% to 81%. Use that statement to find the point estimate P hat and the margin of error E. So you saw that confidence interval of 58% to 81%. So we've just rewritten that as a decimal here. So 0.58 is less than P is less than 0.81. So that lower endpoint is 0.58. The upper is 0.81. P hat is going to be right in the middle of those numbers. So all you have to do is add and divide by 2, and that gives me 0.695. So P hat equals 0.695. And remember, the margin of error, or E, is the distance from P hat to either endpoint. So you want to do your upper endpoint minus your lower endpoint divided by 2, and that gives us an E of 0.115. So if you are ever asked to find your P hat or your E and you're only given your confidence interval, you can do that by just following those formulas. A local news station gives the headline above. Majority of North Carolina residents say government is ran by lizard people. So the article, they say a recent poll was given to 512 residents of North Carolina to see if they believe that the most powerful individuals in our government are actually alien lizards in human skin. 52% of those asked said that they have this suspicion. In fine print below the article, they give this information: an N of 512, alpha is 0.05, and a margin of error of 0.03. So if you're asked what is P hat from that, it did tell you in the problem that 52% said that they had a suspicion. So P hat is 0.52. What is our E? So our E is given. It says the margin of error is 0.03. If you're given alpha of 0.05, then that means the confidence level is 95%. So is their claim that the majority believe in lizard people valid? To do this, you actually need to find the confidence interval. So we're going to find the lower and the upper here. You're going to do 0.52 minus 0.03 and 0.52 plus 0.03. So when you do 0.52 minus 0.03, you actually get 0.49, and then when we add, we get 0.55. So this confidence interval is from 0.49 to 0.55, or 49% to 55%. So their claim is that the majority believe this is true. If they're saying the majority, what they're saying is that more than 50%. But here you can see that our interval is not above 50%. We actually fall into the 0.49 or 49%. So no, it is not a valid claim because the interval is not completely above the 50% mark. So you have to keep in mind that majority means more than 50%. Any confidence interval for P that includes 50% cannot claim that P is a majority. Only confidence intervals where all values are higher than 50% can justify a claim about a majority. Here you can see a screenshot of Excel, and I have done the same problem over and over with just changing my n. So take a look at each of these n values. So you can see those here in row 2. And what happens to the corresponding e value in row 14? What you should have noticed in the previous slide is that as we increase n, e decreases. So n increases, e decreases. So if e increases, then the confidence interval is going to be wider. If e decreases, the confidence interval is going to get narrower, right? Because that's your piece that you're adding and subtracting to your p-hat. Let's look at a new problem. We have study design. Suppose you are a campaigning strategist for a major presidential candidate. Your candidate wants to know if it is worth his time to spend more time in New Hampshire during his tour. If the proportion of voters who support your candidate is very high, then he doesn't need to campaign there anymore. However, if the proportion is too low, it's not worth it to spend more time there, since he will likely not win them over. So your candidate tells you to conduct a survey in order to determine if it's worth it to spend a day or two in New Hampshire kissing babies. You will make your recommendation based on a confidence interval for P. However, you don't know how many people to ask in the survey. So if you're given a level of confidence of 1 minus alpha and a margin of error E, then the minimum sample size needed to estimate P is P hat times Q hat times Z sub alpha over 2 divided by E squared. This formula assumes that you know what P hat is. If you have a previous study, then you're going to refer to that and use that p hat. If you have no prior information, you will use a p hat of 0.5. For this formula, you always round up to the next whole number. Always. It does not matter if your answer is 452.1, you will round up to 453. Okay, so whenever you're looking for a minimum sample size, you always round up to the next whole number. So in Excel, I always set these up the same way. I do my P hat, Q hat, then my E, confidence level alpha, alpha divided by 2. Then I have what I need to find my Z, so 1 minus alpha over 2, and then I'll use that Z sub alpha over 2, or that norm dot S dot inverse, your n, and then you actually can do a round up for Excel, and I will show you guys how to do that. So you're running a political campaign and wish to estimate with 95% confidence the population proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population proportion. Find the minimum sample size needed. First way is going to be if no preliminary estimate is available. The second way is if we know from a previous race that 31% of voters supported him. So just so you can see from this example, this is our confidence level, this is our margin of error. If we know no preliminary estimates, then our p hat is going to be 0.5, and we know a previous race that's 31%, then p hat is going to be changed to 0.31 in the second problem. So you're going to use that information and work through the problem. On the next slide, you're actually going to see how I did my Excel. And again, I always set these up the same way so that it makes it really easy to not make any mistakes. So you can see my Excel here. P hat, and this is from that question 1 where it said that we know no preliminary results. And then, of course, if P hat is 0.5, Q hat has to be 0.5. But you would do that by doing 1 minus your P hat value. E was from our problem. It told us 3%, so that's 0.03. The confidence level also came from our problem, and that was 0.95. Our alpha, of course, is 1 minus your confidence level, and then you can do alpha divided by 2. And then you're going to do 1 minus alpha divided by 2 to get the value you need for your norm.s.inverse. And then to do your n, you want to make sure that you're doing p hat times q hat times your z divided by e squared. And you can see that here, so let me just write that out again. So p hat times q hat times your z sub alpha over 2 divided by e squared. And then you can use that equals round up, parentheses, the value you want to round up, and then comma 0 tells it that you want it to be a whole number. So you just want to make sure that you are, if you use the roundup, you put a 0 there because that's telling it to do a whole number. Here is the second one worked out for you in the notes. And then this is changing your p hat to 0.31. And so you should notice that there's a change in our n. And here it is in Excel for you. And I did the same exact thing, and I used that round up value. And so if you're using the Excel and making sure you're cell referencing, when you go in and make that change to p hat, everything else should then just change for you. A note that you want to pay attention to: the sample size formula does not depend on the size of the population. It depends on the desired confidence level. And you should notice that as you're working through these problems, that as you change your confidence level, your sample size is going to change. You can now do some practice. So of course you have your My Math Lab homework on 7-1 and your lab manual pages 70 to 73. If you have any questions, of course, you can go to the Microsoft Teams channel for Unit 3 questions and post any questions that you have there.